So just I will start with a quick review what we covered last meeting. I will start the story from scratch one more time. So far we have a main system. This main system looks like truss. We are able so far to find how much dead load, snow load, wind load, life load on this truss. So we have different loads: dead, life, wind, snow load. We modeled this truss on RISA analysis 2D, and we did combination between the applied loads, and finally we solved the truss and we found each member will have axial force, which is called P ultimate. This value of ultimate force, P ultimate, can be tension or can be compression. We started last meeting to talk about tension, designing of tension member of truss. Next week on Monday, we will start to talk about if your member under compression. I started last meeting to talk about the tension members, and I told you your member can be single angle, only one angle, with equal legs. So you can find L angle like this, 5 by 5 by 1/2, for example. That means we have equal leg angles. This length equal 5, this length equal 5, and the thickness of this leg equal 1/2 inch. Or an equal angle. We don't recommend this, but anyway, you will find something like this. L means angle, 5 by 3 by 1/2, for example. That means you have a longer leg with 5-inch length, a shorter leg with 3-inch leg, and the thickness for both of them will be the same, 1/2 inch. That makes sense? Sometimes, not sometimes, most of the time, we can combine two angles back to back. Two angles back to back to work together as a member. This angle can be written like this: 2L, and I can write 5 by 5 by 1/2. So if you look to this one angle, the dimensions are equal legs, 5-inch, 5-inch, and 1/2 at the thickness. And this symbol means we have two angles back to back. And I told you last meeting that I will use the double angle most of the time for the top chord of the truss and the bottom chord of the truss. Most of the time they will be double angles. Most of the time your web members, the vertical members and the inclined member, will be only one angle. So these will be one angle, these will be double angle back to back. Anyway, sometimes your angle, two angles, but they can create star shape. Sometimes we can use this shape in your member, but most of the time, this one and this one. We will design our member so your applied force P ultimate, which is coming from RISA, must be smaller than or equal phi Pn. We have two values for phi Pn. Your value of phi Pn to satisfy yielding criteria equal 0.9 time F yield time area gross. Or we have another value for the tensile strength, phi Pn equal 0.75 F ultimate area effective. Which one I'm gonna use? We are going to use the smallest value. smallest one will satisfy both criteria or the two mode of failure. The first one is yielding. The first criteria is talking about the member at the mid distance here. The second one mainly talking about the member at this connection and this connection. As you know, if you look to this picture, your member is connected at this location, at this end, and connected at this end. If you are talking about this position or this part of the member, the second criteria is talking about this case. Second criteria, we are worrying about rupture. If you have bolts, if you have weld, if you have something like this, we are worrying about rupture of the member at this location. But if you are talking about this position of the member, we don't have anything. We don't have anything. This is the reason why we are using area gross, the total area. So this is the case worrying about the member at the midpoint. This point is clear for you. You have to understand this point carefully. We have two criteria because your member has two positions, has two parts. The first part, you have bolts, you have holes, the area gross reduced a little bit. So we have a big concern here. But at this location, we don't have a concern because your member is already, the whole cross section is already working with you. So this is the reason why we have two concerns, two criteria we need to satisfy. And the last meeting also, I started to figure out what is the meaning of area gross. Area gross means the whole area of your member. This is the whole area, regardless bolts or holes or whatever. But we have something called area net. Area net means if you take a cross section here, you will find holes. Holes means we don't have material. We don't have something here to support your force. So we need to subtract these holes from the area gross. So we have two options here. If your holes arranged in arrows and columns parallel, this is a row, this is the second row, or this is a column and this is the second column. This is called parallel arrangement. In this case, your net equal area gross. We can rewrite this expression like this: area gross minus summation d whole plus 1/16 inch time thickness. And I told you last meeting also that summation means if you take a cross section here, or cross section here, or cross section here, how many bolts in each of these cross section? I think in this case it will be 2. So this summation means 2 time d whole. We have expression here, your d whole equal d bolt, the diameter of the bolt, plus 1/16 inch. Let me focus today on the second case. If you have a staggered arrangement, what you mean by staggered arrangement? Later, when we will discuss the design of connection, we will cover more details about this arrangement. But anyway, so far, staggered arrangement means I will put your holes or bolts like this. 1, 1, 1, 1, 1, like this. It's staggered, not regular rows or columns. So I skipped this position and put here. I skipped this position and I put a hole here. That makes sense? This is called staggered. If you have this arrangement of your bolts or holes, we need to use this expression to figure out the area knot. I will rewrite it to a different way. Area knot equal area gross minus summation d whole plus 1/16 as regular inch time thickness. But if you have this staggered arrangement, the area not, area net will be bigger. So I will add another term, which is summation S square divided by 4G time thickness. So there is a good question, but this question is advanced question for your PE exam, for example. If you have this arrangement, parallel arrangement, we have here 6 bolts, and we have the same 6 bolts, but they are arranged in staggered. Do you think area net here will be bigger or area net here? Which area net will be the biggest? I think the area net for the staggered arrangement will be bigger for one reason. Your area net here equal area gross minus summation d whole plus 1/16 time thickness. This is the first case. The second case, area net will be, I'm talking about the same member. If you have the same member, so the area net, area gross will be the same. Area gross minus summation d whole plus 1/16 time thickness, plus that means I will add another part. This part is summation S square divide 4G time thickness. That makes sense? So sometimes we will prefer staggered arrangement because you will get more benefit from your member, better than the parallel arrangement. But anyway, the construction of parallel arrangement is more easy than the staggered arrangement. So let me talk about what is the meaning of S square and G. S square, as explained here, is the horizontal distance between this bolt and the next bolt. This is S. G is the distance, the vertical distance between this bolt and the next one. So assume we have here row and another row. The distance between these rows equal G. And if you have a column here and another column or another column, the horizontal spacing is called S. So S squared divide 4G time thickness. We have an example here. About the staggered arrangement, this one. We have a staggered arrangement. We need to figure out what is the area gross, what is the area net for this arrangement. This is a steel plate with a thickness 1 inch. So this steel plate looks like this. The thickness of this steel plate is 1 inch. The total height of this steel plate equal 3 plus 5, 8, 5 plus 3, 8, so it will be 16 inch. So it's very easy to figure out what is the total area or the area gross of this cross section. The area gross will be 16 inch times 1 inch equal 16 inch square. This is the value of the area gross. Since your arrangement is not parallel arrows and rows, we have staggered. We have a staggered arrangement. So your area net will be computed using this expression, area gross minus summation d whole plus 1/16 time thickness plus summation S squared divide 4G time thickness. This is the expression which is gonna use. Make sure you select the perfect or the correct expression because your arrangement is staggered. It will not be I will not say in the problem it's a staggered arrangement. You have to figure this out. I will explain it one more time. This is the arrangement of staggered, and this is the arrangement of parallel. So please make sure you can figure which one is your case. Okay, let's start. First of all, your D hole. Your D hole equal D bolt plus 1/16. The diameter of the bolt is given. No, wait. The hole are for 1-inch diameter bolt. So please don't be confused. These holes are made for bolts with 1-inch diameter. So 1 inch is the diameter of the bolt. I need to add 1/16 inch. So your value will be 7/16 inch is the diameter of the hole. So this value is 17 divided 16 inch. Go ahead and draw your cross section like this. Your failure can be like this, or like this, or like this. That makes sense? This is the staggered. This is the staggered arrangement. So how many bolts do you have in any of these cross sections? Anybody can answer me? So how much is this summation? Which number I'm gonna put here for summation? Thank you. It should be 3. It should be 3. Remember, the cross section in your parallel arrangement looks like this. Looks like this. Looks like this. So looks like we have 2. Summation will be 2. But in your staggered, your cross section will be something like this. Your failure can be something like this. So in each cross section, we will have 3. That means your summation here will be 3 times. So this one would be plus 1/16 time thickness. The thickness of this blade is 1 inch. And keep in your mind, your area gross is 16 minus. This is how to set up your equation, how to put your numbers. So this is the D hole, this is 1/16, this is the thickness, and this is the number of summation. And I will need to add S squared divided 4G. Your S is the horizontal distance. Horizontal distance between this one and the next one, or the previous one. That makes sense? If you divide your position of bolts like vertical line, so it looks like your S equal 3. So 3 square. Divide 4G. G is the vertical distance between this row and this row, or between this row and this row. The vertical distance looks like 5 inch. Time thickness, which is 1 inch. Time summation. What is the summation here? Summation is the number of inclined line in your section. It will be 2. Guys, look to me here. It's very important. I found all of these examples or problems in the PE. So if you draw here your section, this is the expectation of failure section. How many inclined line here? I found this line or this part and this part. So how many? 1, 2. So your summation here will be 2. Does that make sense? So this 2 coming from this one and this one. That means if you have staggered arrangement like this one, can you see? This one is staggered. So let's draw the expected failure plane. I think like this, like this, like this, like this, like this, like this. So how many bolts? 1, 2, 3, 4, 5. So this is the first summation. Let me draw it, write it here. area net equal area gross minus summation d whole plus 1/16 time thickness plus summation s squared divided 4g time thickness. The first summation here will be 5. How many bolts, how many opening, how many holes in your cross section? 5. But for this one, how many inclined member? We have 1, we have 2, we have 3, we have 4. So this summation will be 4. That makes sense? That makes sense. Your S is the horizontal spacing. This is S. Your G is the vertical spacing between the bolt and the next one. If you have any question regarding this point, let me know. Okay, looks good. So go ahead and find your final area net. For this example, I have my calculator and I can find it. It will be 3 square divide 20 times 2 plus 16 minus 3 times 18/16. Your area net equal 13.525 inch square. As I told you before, area effective, because we are not using area net in our calculation, but we are using something different, which is called area effective. Your area effective, I can assume it at the beginning of your design, 0.75 of area net. So in this example, I can say area effective 0.75 times area net. So it will be something like 10.14 inches square. So maybe in your exam, I will ask you only to figure out what is the area net. I will give you something staggered like this, and you need only to put your numbers to figure out the area net. Any question? If you have any question, go ahead and let me know. We have 2 examples. I will cover them today. One, to make sure your member is safe. So looks like everything is given, but I need you to give me safe or unsafe. So you are checking. In this case, we are making check. Everything is given. But the second one, no, we need to design. This is a real life design example. I don't know about anything except what is the value of P ultimate, which is coming from RISA. Can you tell me what will be the member size? It will be angle. Looks like it looks be angle. Which angle? Which angle I'm gonna use? So this is the case. If you are given the P ultimate, which is coming from RISA, like we did for this truss, how can I figure out the correct angle? So let's start with the first example. Everything is given, but I need to check. So we have long tensile member is constructed by connecting 2 plates as shown. Each plate is ½ inch times 9. So this thickness is ½ inch, and this dimension, the vertical dimension, which is the total depth, equal 9. So if you would like to figure out the area gross for this cross section, it will be ½ inch times 9 inch. It will be 4.5 inches square. This is the first step. If you would like to figure out the area net, you need to figure first before starting. Don't read anything from your problem. because we'll not say this information. Do you think this arrangement is staggered or parallel? What do you think? I need answer. Do you think this arrangement is staggered or parallel? Parallel is correct. Any other answer? Alexander, your answer is correct. Because this connection is confused a little bit. What we can understand that if you have parallel, that means we will have this arrangement. Or staggered, that means I will have this arrangement. But what I'm seeing right now, I have this one, and I have 3 here. Looks like confused for me. Is it parallel or is it staggered? Can you understand what I'm saying? If this bolt, if this one moved a little bit here, and this one does not exist, that makes sense. It will be staggered. But unfortunately, this one is here. And we don't have another one here to make it parallel. So what do you think? I think if you have this situation, which is a very bad situation, I will assume 2 area net, and I'm gonna use the smallest one. The first one will be area gross minus, but this is a very bad situation. I believe you will not find it anymore, but we have it. You will find only this case or this case, but combination between both of them, I promise you will not find it, but I provide it to get more practice and more experience. Summation, d whole plus 1/16 time thickness, as your section looks like this. So this area gross will be 4.5. This summation will be 3 because we have 1, 2, 3 bolts. Your D hole diameter looks like the given is the bolt diameter. D bolt is given 1 inch. So D hole will be 1 inch plus 1/16. So it will be something like 9/16. The hole will be 9/16 plus 1/16, and your thickness of this blade is 1/2 inch. So your area net, assuming for this one is parallel, your area net will be 9/16. It will be 10/16. 10/16 time 1/2 time 3. Your area equal 3.56 inch square. Another suggestion is we have this failure. As it's staggered. So your area net will be area gross minus summation D whole plus 16, 1/16 time thickness plus summation S squared divide 4G time thickness. If you look here, you don't need to continue your calculations because you can judge. This D hole will be 9/16. And this summation, since we have 1, 2, 3 bolts, so looks like this term will be the same like this term. You still need to add something else. Do you expect the final answer for area net coming from this one will be 3.56 or something greater? It will be greater, 3.56. That means the final answer, your area net will be I'm sorry, 3.56. Let me continue to prove it for you. We have here summation. This summation will be, we have this one and this one, looks like 2. Your S square looks like the horizontal distance, 2.75 square. Divide 4G, your G is the vertical distance, looks like 2.5. Time thickness is 1/2. Your answer will be 4.31. So the two cases, if you consider this connection parallel, it gives you area net equal 3.56. If you consider this connection staggered, it will give you 4.31. I'm going to use the smallest value, which is 3.56. So the final answer is the area gross for this cross section is 4.5 inches square, and your area net will be 3.56 inches square. This is the final conclusion. That makes sense? But the problem does not ask for area net and area gross. We need to figure out what is the design ultimate strength. What is the design ultimate strength? Phi PN, this called design ultimate strength for this member. We have two keys, 0.9 area gross F yield, or can be written like this, 0.9 F yield area gross, and 0.75 F ultimate area effective. I forget to say area net equal this number, so area effective will be 0.75 area net. So your value will be 3.56 times 0.75. It will be 2.67. So this number will give you 0.9 times F yield. Read your problem carefully. For F yield, the type of steel is given here. Grade 50 with ultimate strength 65. This is the value of F ultimate. This is the value of F yield based on this type of steel. F yield equal 50, F ultimate equal 65. So F yield equal 50, area gross equal 4.5. So what is your value? The second one will be 0.75 times F ultimate 65, area effective 2.67. So what is the value here? 0.9 times 50 times 4.5. I got 202.5 kb. In second case, 0.75 times 65 times 2.67, I got here 130.16 kb. Looks like your member can support this force to satisfy yielding. And your member, the same member, can support only 130.16 kb to avoid any fracture of the connection. So the final conclusion is your design strength of this member will be 130.16 kb. If you are given P ultimate from RISA, coming from structure analysis, make sure your P ultimate is smaller than or equal Phi PN, which is 130.16 to make your member safe. That makes sense? That makes sense. This is how to make sure your member is safe if everything is given. But you need only to figure out what is the design strength of your member, which is phi PN. You have two values, satisfy yielding, satisfy fracture, which value I'm going to use, the smallest value. If you have any question, let me know. One more example. In this example, I will assume so that the smallest value between yielding and fracture is the answer for design ultimate strength. Yes, sir. Yes. The final answer in the previous example, yes. Your design strengths, design tensile strengths of your member will be this value. Hey, I remember last semester, we have something like this in your exam, and I'm asking to figure out what is the design strength. Everybody stopped at this line. You have to tell me what is your final answer. Don't say, let it to me. I have two values. Which value? You have to tell me which value. Is it 202.5 kb or 130.16 kb? Please don't stop here. You have to continue and let me know what is your final conclusion. The value of design tensile strength equal 130.16. The smallest value. Okay. For this angle or for this member, I'm gonna assume we are not given this information. We are not given this information. The size of your angle is not given. That makes sense? So we have member, this one is tension member. Like any tension member in your truss. Like any tension member in your truss. I don't know which one. Any member, but it's a tension member. And the value of P ultimate is given. Looks like it's not given here, but we can find it 1.2 dead load plus 1.6 life load. This value should be given from RISA directly. If you already solved your truss, this value will be given. But in this problem, the problem giving us the dead load 35. And the life load 15 only. So the typical combination is 1.2 dead plus 1.6 life. Since we don't have snow, since we don't have anything else. So the value of P ultimate equal 1.2 66 kb. This value should be calculated from RISA, will be given directly. We need to figure out what is the size of angle you will use for this member. Do you think angle 5 by 5 by something, or angle 4 by 4, or angle 3 by 3, or angle 6 by 6 by something? Which angle I'm gonna use to satisfy this P ultimate? This is the point. That makes sense? So this is the real design example. since you solved your truss and you can figure out what is the value of B ultimate in this member, how can I use this B ultimate to figure out the required member? Very easy step. Please pay some attention. How to design your member. P ultimate 66 cap. First step, I'm gonna assume your P ultimate equal 0.9 if yield area gross. Since we have two steps or two criteria for design, the first criteria is 0.9 if yield area gross. I cannot use the second criteria so far. Do you know why? Because I cannot figure out the area effective. Anyway, so I'm gonna assume your P ultimate, which is here, equal 0.9 if yield area gross. P ultimate equal 66. 0.9 time if yield. Go back to your problem. What type of steel we are using in this example? The steel is 36. Area steel equal 36. So for steel A36, your F yield equal 36, and your F ultimate equal, I think, 50. This information will be given, don't worry, about the type of steel. So F yield will be 36, and the area gross, I don't know. Can you tell me what will be the area gross? I can tell you. So 66 divided by 0.9 times 36, I need area gross equal 2.037 inches square. I need this area gross equal this value to satisfy or support this applied force from structure analysis. Okay, what else? I need to figure out which angle I'm gonna use. This is the next step. Go ahead and open the tables for your angles. Open the table for your angles. And then look for the column which is called area. And go ahead and choose an angle that satisfies 2.037. So it looks like this angle is very big, but it works. I cannot say it's wrong, but you are wasting your money. It's not economic solution. I need only 2 point something. So how can you will select 16.8? You are kidding. So go down to figure out a smaller. Looks like we still, it's very big, 3.67. Design of steel is very sensitive. Go down more. Area. Here you go. We started to see 2 point something, 2 point something, 2 point something. All of these can work. Keep in your mind also, I recommend to use equal leg. So if you select this one, for example, it's 5 times 3.5. It's not equal leg. So I need to look more. This one is equal leg. This one is equal leg. This one is equal leg. So go ahead and start from there. You are requiring 2.037. What do you think about this one? 2.26 will satisfy. That works. We have here 2 by 2. No, this one will not work. 2 by 2 because your area is 1.37. Looks like it's smaller. So this one works. And what about this one? No. This one is not equal leg. I'm sorry. And this one not equal leg. Yeah, this one can be. Your area here is 3 point, 2 point, 2.5, 2.1. I think this one can work. 2.1 will work because your area is 2.037. So 2.1 will work. So we have another option, 3.5 times 3.5 times 5/16. This one can work. Also, if you go up more, this angle is equal angle, equal legs. So we can use this area, 2.4 will work. So you have 4 by 4 by, I think this 5/16. So this one will work. So you will ask me which angle I'm gonna use. All of them works. All of them will satisfy your design. That makes sense? So how to design your member? Very easy. Go ahead and put B ultimate equal the first criteria. Go ahead and find your area gross. Go ahead and open your table. I highly recommend to use equal leg. So I will not select from here. From this one can work also. It's a 5 times 5. This one I don't recommend. I would recommend the equal legs. Go ahead and select the area gross, which is very close to your value. So I will select, for example, angle, and should every student has a different selection from the other student if you are not solving together. So I will select this one, 3.5 times 3.5 times 5/16. So your angle design will be, this dimension is 3.5 inch, this dimension is 3.5 inch, and the thickness is 5/16. But I have to check the second step. I need to make sure your P ultimate is smaller than or equal 0.75. F ultimate area effective. So area gross for your selection from this table, the actual area gross 2.1 inch square. Go ahead and find your area net. Area net equal area gross minus. This connection looks like it's parallel. So it will be minus summation d whole plus 1/16 time thickness. Your area gross is 2.1 minus summation. If you put here cross section, the number in each cross section is 1 time d whole, the diameter of your bolt 5/8. So d whole will be 5/8 plus 1/16. It will be 6/8. I'm sorry. It will be 11/16. Sorry. So 11/16 plus 1/16 time thickness. Your thickness is 5/16 because you select the thickness, which is 5/16 inch. So your area net equal (1.86), and your area effective equal 0.75 area net. So your value will be something very small, 1.4 inch square. Go ahead and put your value for area effective 1.4, your value for F ultimate equal 50. What is the final value? 52.5. Unfortunately, 52.5 kip, which is unsafe. Which is unsafe. You select a member that satisfy this condition. But unfortunately, this member will not satisfy this condition. What is the solution? Select a different member with bigger area gross. So we need to go back and probably we can select this one, 4 by 4 by 5/16, and try. So 4 angle 4 by 4 by 5/16. Go ahead and find your area net, area effective, and make sure 0.75 if ultimate area effective is greater than or equal P ultimate. If it is, okay, your selected member will be good. If it's not, go ahead and try another bigger member. Does that make sense? But I think this one will be safe. This is how to design. So I highly recommend it. Do you know what is the problem for the first selection? I will let you know. You are looking for area gross equal 2.0. It was be 0.0 something, 2.037. And you selected area 2.1, which is very close. Be generous and assume or select one bigger from the beginning. Don't just very close to what is you are looking for. Don't select the closest. No, be generous and select a bigger area gross to satisfy the second condition. That makes sense? Do you have any question? Do you have any question? Guys, if you have any question, let me know.